40 tons of raw cassava
Paddle mechanisms scrub the roots against each other.
from the intake pit. The cassava now fully peeled.
Primary separation of fiber and starch.
Any bag failing the weight check is automatically diverted for reprocessing. In the heart of the American agricultural belt, cassava production begins on a massive industrial scale. Specialized extraction units replace manual labor, clearing 10 acres per hour. Precision blades lift the tubers gently to preserve the starch integrity inside. Vibrating belts shake off 50% of the field soil before the crop even leaves the ground. Synchronized logistics ensure the harvester never stops moving, not even for a second.
Once dug, the clock starts ticking. Cassava begins to ferment within 24 hours.
Field technicians verify starch content instantly before the cargo is cleared for transport. A fleet of 50 trucks cycles continuously between the harvest zones and the processing plant.
Every load is weighed to the kilogram, tracking yield data for the entire operation.
Automated probes ensure no spoiled roots enter the high-quality flour line. At the intake bay, gravity takes over as the raw material meets the factory system.
40 tons of raw cassava are unloaded in less than 3 minutes.
Steel drag chains pull the heavy load from the intake pit toward the pre-cleaning station. Vibratory separators remove field debris that could damage the delicate slicing machinery ahead. The journey transforms from dry transport to a high-volume hydro-transport system.
Paddle mechanisms scrub the roots against each other, softening the stubborn soil.
High-pressure nozzles strip away the remaining field clay, revealing the brown skin.
With the harvest complete and the dirt removed, the true processing begins inside. From the intake pit, the cassava begins a subterranean journey toward the pre-cleaning facility.
Steep incline belts transport the raw payload to the height of the gravity-fed cleaning towers.
Before entering the plant, a rotating drum separator removes the last of the loose field sand.
High-powered magnets protect the milling equipment by catching any stray metal fragments from the harvest. Rubber star wheels gently separate tangled clusters to ensure every root gets an individual wash.
Water becomes the primary transport vehicle, cushioning the cassava against impact damage.
Density-based traps allow heavy stones to sink, while the starch-rich tubers float onward. Automated rakes skim the surface, removing any organic waste that isn't the root itself.
To conserve resources, the transport water is continuously filtered and recirculated.
An Archimedes screw gently elevates the wet cargo to the facility's intake level.
This complex vascular system ensures a constant, regulated feed rate of cassava into the plant.
Surge hoppers hold 50 tons of material, smoothing out any interruptions in the delivery trucks. Vibratory feeders organize the chaotic pile into a single, manageable layer for processing.
Even with advanced automation, the human eye performs a final check before the peeling stage.
Only the highest grade cassava is permitted to enter the main flour production building. Crossing the threshold, the raw roots leave the exterior logistics zone forever. Inside this facility, the humble root will be transformed into a global food staple.
The transport phase is complete,
Now, the chemistry of extraction begins. Covering 300,000 square feet, this facility is a fortress of food safety.
Processing 200 tons of cassava daily requires a synchronized human workforce.
Strict contamination protocols begin before anyone steps onto the production floor.
Automated scrubbers ensure no outside soil tracks past the hygiene barrier. High-velocity air showers strip away microscopic dust and loose hair.
Inside, the environment is controlled to the degree of a surgical operating room. The central nervous system of the plant monitors every valve, motor, and sensor. Real-time data allows operators to adjust the flour processing parameters instantly. The raw roots, now inside the clean zone, travel toward the dry cleaning stage.
Gravity is utilized wherever possible to move tons of material with minimal energy. Human oversight remains the final failsafe in a fully automated system.
Before water is added, a dry tumbling cycle knocks off the last of the stubborn crust. Friction alone removes the outermost layer of the cassava bark. Powerful cyclones extract dust instantly to prevent any airborne contamination. High-intensity inspection lighting reveals imperfections invisible to the naked eye in normal light.
Foliage. Any root showing signs of fermentation is immediately pulled from the line.
With the dry prep complete, the system prepares for the intensive hydro-peeling phase.
The facility is primed, the staff is ready, and the deep cleaning is about to begin. The hydro-cleaning stage begins with total immersion, loosening the stubborn soil crust. Mechanical agitation scrubs the surface without damaging the starch-rich interior. Inside the abrasive peelers, rough rollers strip away the toxic outer brown bark.
Precision friction removes the cortex layer while minimizing the loss of usable white flesh.
Power jets flush away the peel residue, leaving only the pure, starchy core.
Waste skins are immediately separated and diverted for use as organic compost or animal feed.
Now fully peeled, the stark white roots enter the critical manual sorting zone.
Skilled trimmers perform surgical cuts to remove woody ends that machines might miss.
And quality control is zero tolerance. Any discoloration could ruin the flour's brightness.
For the ultimate purity check, the flow is handed over to advanced optical sorters.
Lasers analyze the surface texture and color density at a rate of 500 objects per minute.
The algorithm instantly identifies any route that deviates from the perfect white standard. Compressed air jets fire with millisecond precision to knock out defects in midair.
A final polishing rinse ensures the cassava is 100% free of peel residue.
A secondary metal detector safeguards the high-speed chopping blades waiting ahead. The raw material is now pristine, chemically stable, and ready for destruction. Screw augers force-feed the roots into the high-speed raspers at a constant pressure.
Cleaning is finished. Now, we break the cellular structure to release the starch.
The rasper spins at 2,000 RPM, turning solid root into liquid pulp in a fraction of a second.
Total cellular destruction is required to liberate the starch granules locked inside the fiber.
The result is a coarse mash containing starch, fiber, and fruit water.
Heavy-duty pumps drive the viscous slurry toward the extraction stage.
This battery of centrifugal sieves is responsible for the primary separation of fiber and starch.
Centrifugal force drives the starch milk through micron-sized screens, trapping the fiber inside.
The fibrous waste is ejected immediately, leaving behind the valuable crude starch milk.
The extracted liquid is rich in starch, but still contaminated with sand and protein.
To protect the final product, hydro-cyclones use vortex physics to remove microscopic grit.
Heavier silica particles are forced down and out, ensuring a grit-free flour. The heart of the purification process is the high-speed disc nozzle separator.
Spinning at 4,000 revolutions per minute, it generates 5,000 Gs of force. The machine splits the fluid by density, ejecting the yellow fruit water and concentrating the starch. A countercurrent wash cycle scrubs the starch granules with fresh water one final time.
Automated densitometers ensure the slurry reaches the specific gravity required for drying. The brown roots have now been fully transmuted into a stream of pure, liquid energy. Agitators keep the starch in suspension, preventing it from turning into solid concrete at the bottom. The liquid phase is over. Now, the starch must be stripped of its water.
Before heat is applied, mechanical centrifuges remove the bulk of the water content.
The centrifuge spins until the liquid becomes a dense, semi-solid starch cave.
Hydraulic blades shave the dewatered starch from the drum walls with micron precision. Screw conveyors break the solid cake back into a moist, crumbly powder. A dedicated furnace generates a clean, hot air stream regulated to exactly 180 degrees.
In the flash dryer, the moisture evaporates instantly as the particles are suspended in hot air.
The starch travels vertically for 4 seconds, drying completely before it hits the top.
Cyclonic action separates the finished flour from the humid exhaust air.
Rotary valves discharge the product without breaking the vacuum seal of the dryer. The flour enters a fluidized bed to cool down immediately, preventing heat damage. Sensors confirm the moisture content has dropped to a shelf-stable 12%. Vibrating sifters classify the flour, ensuring uniform particle size for baking consistency.
Only the finest particles pass through the final mesh. Anything coarse is rejected.
A final magnetic array guarantees the product is pure and safe for consumption.
The result is a silky, gluten-free flour ready for the global market.
These silos buffer the production, holding up to 200 tons of finished product. Pneumatic lines transport the flour to the packaging hall without human contact. The flour is made. Now, the high-speed automation takes over for packaging. High-speed valve packers handle the bulk industrial orders, filling heavy bags in seconds. Fluidized air pushes the flour into the bag, maximizing density while minimizing dust.
Ultrasonic sealing locks the bag instantly, preventing any leakage during rough transport.
Vibratory flatteners shape the bags into perfect bricks for stable stacking. Every 25-kilogram unit is digitally stamped for total traceability.
Industrial scales verify the weight within a 10-gram tolerance margin. Any bag failing the weight check is automatically diverted for reprocessing. Heavy lifting robots take over the back-breaking labor of palletizing. Custom grippers handle the paper bags gently to avoid tearing, despite the speed. Calculated stacking patterns lock the layers together for maximum stability. Protective slip sheets are inserted to prevent friction damage between the layers.
Once the 1-ton stack is complete, the automation system conveys it to wrapping.
Rotary arm wrappers secure the load with high-tension stretch film. The wrapping creates a waterproof seal, preparing the cargo for ocean transit. Automated labeling ensures the pallet is identified and tracked globally. Laser-guided vehicles transport the finished pallets without a human driver in sight. Navigating by laser triangulation, the fleet moves with mathematical efficiency. While the bulk lines feed the warehouse, the precision lines handle the consumer packs. While bulk shipments serve industry, a separate precision line handles the consumer retail packs. Vertical form fill seal machines create the bag from a single roll of printed film. Heated jaws fuse the plastic instantly to create a durable, airtight bottom seal. Servo-driven augers dose the product with an accuracy of 1/10 of a gram. A blast of nitrogen displaces oxygen, extending the shelf life of the flour by months.
Cycling at 60 bags per minute, the machine is a blur of continuous motion.
Any package underweight by even 2 grams is instantly removed from the stream. Consumer safety is paramount. A secondary metal check scans every retail unit.
Accumulation tables buffer the flow, preventing bottlenecks between bagging and boxing.
Automatic case erectors build the shipping boxes faster than any human hand.
Delta robots use vision systems to orient and pack the bags into cases with geometric perfection. The cases are sealed and immediately prepped for the palletizing queue. Shipping data is married to the production batch, ensuring full supply chain visibility.
To save floor space, spiral conveyors lift the finished goods to the overhead logistics network. While the product moves to storage, samples are being rushed to the on-site laboratory. Random spot checks occur every hour to verify the automated systems are drifting.
Behind soundproof glass, the final phase of scientific validation begins.
The packaging is perfect, but the chemistry must be proven.
Every production batch undergoes a rigorous 20-point analysis before release.
Analytical balances measure samples to the 4th decimal place for absolute chemical accuracy. To test chemical stability, the flour is dissolved into a precise suspension. Maintaining a neutral pH is critical for the flour's performance in baking recipes.
Viscosity meters simulate the baking process, measuring the peak gelatinization of the starch. A perfect viscosity curve confirms the flour will thicken sauces and doughs correctly. Spectrophotometers verify the purity of the white color, ensuring no peel residue remains. Infrared analyzers double-check the inline sensors, guaranteeing moisture remains below 13%.
Microscopic analysis inspects the physical integrity of the individual starch granules.
Under polarized light, undamaged cassava granules display a distinct cross pattern.
ELISA testing confirms the product meets the strict standard of less than 5 parts per million of gluten.
Chemical assays verify that the natural cyanide found in raw cassava has been completely eliminated.
Microbiological plating screens for yeast, mold, and pathogens before the lot is cleared. Samples are incubated for 48 hours to prove total sterility. All results are uploaded to a central server, generating a certificate of analysis for the customer.
A retention sample is kept for 2 years, allowing full traceability for the product's lifespan.
With the science complete and safety verified, the batch is officially released for distribution.
The test results are in, and the logistics team is already moving into action.
The distribution center serves as the final buffer, holding 5,000 tons of inventory.
Precision operators maximize vertical space, stacking pallets 4 levels high with ease. Every location is digitally mapped, ensuring the first-in, first-out protocol is strictly followed. Climate-controlled storage preserves the flour's functionality regardless of the season. When an order drops, the logistics team has less than 2 hours to stage the cargo. Logistics partners synchronize their arrival times to keep the loading bays active 24/7. Hydraulic dock levelers create a seamless bridge for the heavy equipment to enter. Efficiency is key. Operators pack the container tight to prevent shifting during transit.
Inflatable dunnage bags lock the cargo in place, absorbing road vibration.
40,000 pounds of premium cassava flour are now ready for the highway.
Tamper-proof seals guarantee the chain of custody from our factory to the customer's door.
From the fields of the South to bakeries across the nation, the journey is complete.
What started as a rough tuber in the dirt is now a pure, versatile food ingredient.
It takes heavy machinery, precise chemistry, and hundreds of skilled hands.
We don't just mill flour here. We engineer consistency for the world's food supply.
And this is how modern factories produce cassava flour, from start to finish.
Engineering nature, one harvest at a time.
Thanks for watching Factory Systems Pro. See you on the next line.